last wee bit on statistics then. We'll have a wee look at scattergraphs. Now this kind of really comes more into straight line than statistics. And you'll see why when we go on to the actual questions. They are very similar to your straight line questions. Always good to do though, always good to revise straight line. It is one of those topics that is generally quite difficult to do. Okay. Scattergraphs then are used to look at the relationship between two different variables. Values are plotted onto a graph in the exact same way that coordinate points would be plotted. And we're looking at what happens if we change one variable, what happens to the other variable. Sometimes there's a cause and effect if there's a relationship between the two. Sometimes there's no relationship at all. The relationship between the two we call the correlation. We have three different types of correlation. We have a positive correlation, we have a negative correlation, and we have no correlation. If we look at a positive correlation, if both variables are increasing, we get a positive correlation. So if you look at the diagram here, if you imagine drawing a line through these points, it would go something like that. That would be a line with a positive gradient because it's going up from left to right. So as the height increases, the weight also increases. So it's a positive correlation. A negative correlation would be like this diagram. If you imagine drawing a line in here, it would slope down this way. So it would have a negative gradient, and as one of them increases, the other one decreases. So here, as temperature is increasing, the sale of gloves is decreasing. The third one is no correlation, no straight line I could draw here, there's no pattern at all. If we look at the two things, we're talking about shoe size and maths result. It doesn't matter what size feet you have, it doesn't affect how you get on in a maths test. So for this one, there would be no correlation. Some examples then. If we're looking at this one, fuel consumption of a group of cars is recorded. The scattergraph shows the relationship between the fuel consumption F and the engine size E. A line of best fit has been drawn, and we want to find the equation of this line of best fit. Now this is why it becomes very much like a straight line question. Okay. The only real difference is when we're looking at this diagram and we're looking to find our equation of the line, or a line of best fit, is we need to make sure that we are picking points that are on the line. So we can't pick, for example, this point here, or this point here, or any of these ones that doesn't lie exactly on the line. We can only pick points that lie exactly on the line. I managed to change page there without trying to. Sorry about that. Okay, so if I'm looking at this graph here, there's 2 points that really jump out to me. I've got this point here, which is the point 1.5, 14, and remember when we're looking at coordinate points we always go along first, and this point here, which is the point 3.58. So they're the 2 points that I'm picking out. Now I've got 2 points, no different from the straight line question. So I'm going to label my points. It's x1, y1, x2, y2. Gradient of the line, difference of the y's over the difference of the x's. So 8 minus 14 over 3.5 minus 1.5. 8 minus 14 is minus 6, 3.5 minus 1.5 is 2, so gradient of negative 3. We should expect a negative gradient here. The line is sloping down the way. So I've got my gradient, I've got a point on the line, doesn't matter which of my points I'm going to use. I'm going to take the first one, 1.5 and 14. So that's my A, that's my B, that's my M. So y minus b is equal to m into x minus a. So that y minus 14 is minus 3 times x minus 1.5. Multiplying out the brackets, goes to minus 3x plus 4.5. I need to bring my minus 14 over. So 4.5 add 14 gives me 18.5. And just one last step that I need to do. I don't have x and y. Instead of an x, I've got an e. Instead of a y, I've got an f. My answer needs to reflect this. So I can't have x and y. I need to make this f equals minus 3e plus 18.5. Okay, part B. Mears car has an engine size of 1.1 litres. So that means E is equal to 1.1 litres. Use your equation from part A to estimate how many kilometres per litre he should expect to get. The number of kilometres per litre is my F. My formula is F equals minus 3E plus 18.5. E is 1.1. So I get F is minus 3 times 1.1 plus 18.5. I keep going without my calculator, I've come this far. So I get minus 3.3 plus 18.5. So F is 15.2. And that would be 15.2 kilometres per litre if we want some units in there. Okay, let's try a second example. The cost of a journey with Tom's taxis depends on the distance travelled. The graph shows the cost P in pounds of a journey with Tom's taxis against the distance travelled B. So point A, this point here, represents a journey of 8 miles at a cost of £14. So A would be the point 814. Point B represents a journey of 12 miles, which costs £20. So point B is the point 1220. Let's find the equation of the line in terms of P and D. So first thing I'm going to do is find my gradient. So I'm going to label my points x1, y1, x2, y2. Gradient formula, difference of the y's over the difference of the x's. So we get 20 minus 14 over 12 minus 8. 6 over 4, which is 3 over 2. Equation of a line is y minus b is equal to m into x minus a. I'm going to pick just this point here for AB. So I get y minus 14 is equal to 3 over 2x minus 8. I'm going to take my 2 from here. Here it's dividing. I'm going to bring it over here and I'm going to multiply, but I need to remember to multiply everything by 2. So I get 2y minus 28 is equal to 3 into x minus 8. Multiplying out the brackets then, so 2y minus 28 is 3x minus 24. Bring this minus 28 over, becomes a plus 28. Minus 24 plus 28 gives me plus 4. Last thing I need to do, don't have an x and a y, I've got d and a b, no, d and a p. So I get 2p equals 3d plus 4. Part B, calculate the cost of a journey of 5 miles. So the journey is the distance, is 5 miles. I want to find the cost. So I get 2p equals 3 times 5 plus 4, just putting 5 into my formula for D here. So 2p is 3 times 5 is 15, add 4 is 19. So p must be half of that. Half of £19 is £8.50. Okay, that's the last wee bit on scattergraphs then.